Так, коллеги,
My name is Maksim Rodnenkov, colleagues, and we're going to talk about automation of software and hardware packages. I've been doing testing for 10 years. A little bit of background for my company Infotex. We have software for Windows, Linux, iOS, and Android. We test software and hardware packages. These are services where we put our plugins or firmware that need testing. So, what do you do if you have 10 or 50 platforms like that? In fact, these platforms are plentiful. They should be able to do release testing, cluster testing, and testing of different products between themselves. There are various kinds of platforms, server platforms, IP platforms. And what do we test for? We test for power failure, for overload, and what we do is we use firmware mostly. They need to be managed, and for that we use Comport or RS-232. Of course, there should be network communication, and you need to create a schedule for test runs, because these are not virtual things, these are pieces of hardware. So what we did first was to design and release automatic testing block, which is connected to all of our software and hardware complexes. One such system services 6 platforms. It is controlled via network. So we created the first auto rig, which is shown on this picture. It has 2 communicating elements. The schematic is pretty simple, but it made it possible to automatically test systems without having to manually configure them. Once we launched the first auto stand, we decided to test using a bunch of complexes. So now we have a lot of these bags. Initially, it was a process created by guys who used to do it manually, who decided to go automatic. So we wrote initial tests, scripts using a single engine, which was a mistake, put together a simple schedule, and that script sent results of testing to our emails. Our auto stand kept on growing. We created test run schedule by hand. We have about 30 software hardware complexes. It was done only at night because debugging was pretty active. We didn't have any interface. We did it within a code, so entry threshold was pretty high, and it was all hardwired. We decided to grow further, and first thing we wanted to improve was to create an interface. We began with a web interface. In order to plan and select tests, report generation, there are different reports generated for different products, checklists for different types of testing, including manually. These checklists help you monitor the health of product. Test health, automatic, manual, loading. We use the web interface for that. We also have something sort of a dashboard to monitor product health. We created a web constructor for writing auto tests, which does not require any knowledge of programming languages. One of the key challenges was creating a timetable or schedule. If you made a mistake there, it could result in the total failure of the product. In order to do a test, you could only launch it during production to represent the end product. And for editing, we needed to know Python. Here you can see the planner's work logic. Don't be scared, it's just for purposes of an example. In simple terms, one test normally takes 1 to 3 hours, which is different from iOS, Android, and others where tests take seconds. In our case, it's hours. A total number of tests per product is about 1,000. Running so many tests per night is a pretty tall order, and that's why we need to have some sort of schedule. What we do is first we look for the oldest script, then we look for a bug which was targeted by the script for the longest, which makes or refreshes this script. So every night a new set of tests is launched, resulting in a full coverage diagonally. One night we have a various combination of codes and platforms coverage. A full testing cycle for a product takes 2 to 3 weeks, although it depends. The cycle is dynamic, meaning it doesn't work or it doesn't circle back. It takes into account manual launches of auto tests and loading on servers. And the first run for a new product is completing by diagonal. This is a snippet from our product test schedule. The green marks cases that we run, and blank spaces indicate areas where bugs are not supported or maybe Wi-Fi is not available. This is a launch map for one product in its entirety to compare the scale. Product health report gives you a picture of the current condition of a product. It's good for identifying logical failures. If it's on the horizontal line, it means that there is a functional issue. If it's on the vertical line, it means the software-hardware complex was compromised. Test reports on the left-hand side are successful, on the right-hand side are unsuccessful, and you can customize that. We still have a lot of issues which need to be addressed properly.
So we tried to solve it with the help of JIT, and we did different branches for different products, but it didn't work. As long as we had 5 or 10 branches, it could work. Then we had 30 and then 50 plus, and it became quite challenging. So we had to distribute codes between branches, products, and have to work on the engine for it to work. So we could only upload the new function in a week, although it took us only 2 days to make the feature. Then from we transferred from Autotest to web. Perhaps it's a separate story, but for all the tests, we had the so-called white and black checklist, or lists rather. The white list is launched on this spec, on this product, and black list doesn't run. So that's how we solved this problem, and there are certain issues inside the scenario. This is how what we do. We use those two lists to address it. But we also had to separate the framework code from the auto tests. And this is still ongoing. So we took out about 70% from the engine, but there are thousands of tests, so it's still ongoing. As I said it before, we ended the interdependence between projects, and now the reports of auto test are tied directly to scripts, and so we can click on what has gone down, and then we go to web interface of the scenario to see what's happening. This is not just a link to depository, and this is how you can run a test there. And also, now you don't need to know the programming languages if you're automator, because there are units like this, those are steps, and that's the auto test which is to be run. Mostly this is about sending and receiving results. Basically, this is it from me. I was quite quick, but my message is think about the structure well in advance. So what actually didn't work for us, we didn't think about the auto stand architecture from day one, and we had this looked very sloppy, and we had took us quite a while to rectify it. Don't put all the eggs in one basket, like in one repository. It really was quite costly for us. And sometimes you don't need to automate things. Some things can be easily checked manually. This is it from me. Questions, please. Thank you very much for your presentation. Yes, hello. Thank you for your presentation. I have several questions. First, you talked about the metrics assembly. So, what stacks did you use? How did you monitor this? Maybe a few more words about that. So we collect data with scripts, and there's nothing special about it. There are some load tests that test stability. So, and that's a separate team that takes care of that. But then you aggregate it in where? Yes, that's. And then also a question on database of test date scenarios. Yes, we do have this database like what I showed you. This is in the base. It's all in the base. Quite a solution. And the last question, so a few more things. it's not just the steps, but also the scripts that can be done. They could be found in the repository. This is really cool. And the last one, you showed a couple of reports. Those reports were quite unusual. How do you generate them? Like this one. This is a complete matrix of all auto tests. I think you can see it better here. And horizontal line includes packs, and vertical line includes scenarios. So this is how we run those tests. We wrote it ourselves, and we have several of those reports. Some of them tables look like tables, some of them look like matrix, the complete stats, like how many tests were run, how many were down, and there's also a list for testers who break it down. So it's all manually. So it's just an Excel. No, this is web interface automatically generated, but you wrote it yourself. Thank you. Thank you very much. Hello. Am I correct in understanding this? You're using a pattern? No, we're using interface, web interface, but the engine. What does it run on? This is Java framework, our own development, but you can hardly find those Django and Python. That's what we use for interface. There's also a web interface server, and in every auto stand you can run unit auto stand in Java, and that's how you test it. So each test case is just the procedure. How does that procedure run? Or you combine them? No, we can optimize that process, but on the other hand, there's some disadvantages. Something can go askew, and then the other test will become no longer valid, and the next test will go down. So this has to be broken down. We need to know the result of the test. So we have empty device that run the test with parameters, and when we turn off the pack, the next test we run. So it gets a new patch and we get a new device. Last question. As you delve deeper and deeper into your program, so what would you advise to switch from manual to automation? Is there a ready-made TMS that can work? Of course, to test hardware, electronic block, well, this has to be included. Honestly, to test hardware, I know no analogous things. Therefore, we had to do it ourselves. Then one more question is an offshot from that. How many person hours did you have to spend? A lot. This auto stand is about 10 years old. It was originated before I came on board. It's lots of temporary fixes, and but well, it depends. A couple of seniors can do it. For example, this could be turning on and turning off. You can use smart sockets that can do it themselves. If you can turn it on the network, then you don't need to use the pad for console. So thing is that as long as you deploy the keys, you cannot tune in through the network. You can use scripts, but this is just the first version. I need to think about the architecture, how it has to be scaled up, because it was quite costly. Yes, of course, those reports, visual, those are quite important as well. You can use a lure, but I don't like a lure because it's overloaded. It's hard to analyze it. One more question. Can you adapt this on request? We haven't thought about it, but I can ask. Okay, we'll get in touch. Thank you. Other questions, please? Thank you for your presentation. My question is, there was this slide test case based on UI elements. This one. I don't know about the hardware and firmware. Maybe UI elements could be used, but sometimes when the code is unknown, then if something goes wrong, what stays behind? How stable is it? Is it flexible in terms of firmware? Because as far as software is concerned, and when a new version is available, things break down, and then you have to talk to other people to solve the problem, and it doesn't run. Maybe it doesn't work like that for firmware. Well, two things. Whether such functions should be automated, that's a big question, because auto test, it's a regression testing mechanism. This is stable. This is something that is used all the time. In principle, it doesn't matter web interface or you just click it manually. The manual testers can do it so well. Or you can do it Python, Java, whatever. If it's stable auto test, it can run for a long time. If it's a new function, then it's not going to run well. It's going to change quite often. And there are metrics that help calculate the advantages of automation. But this should be done manually rather. Well, I understand, but auto tester would write it. It's the code. It's himself would collect the elements, or would you give some analytics to him, or how does it work out? No, the tester does everything himself, manual testing. So we don't automate the cases that were not tested manually. Then you click additional steps, and that's how it works. And then it's not an issue. Yeah, I understand. Thank you. Any other questions? No more questions. Then let's gift a T-shirt to someone. I liked the second one. Thank you. I'd like to remind you, you have smiles. This is you can use to provide comments. Thank you very much. Thank you.